So today we're going to be finding the area of the region between two curves. Using integrals, you can find the area of a region under a curve. But in this application, you can also find the area between two curves. So f at x, our first function is going to be cos x. Our second function is sin x. I'm going to write out the question actually. So find the area of the region bounded between y equals sine x and y equals cos x. The boundary, this should give you a boundary, is going to be x equals 0 to x equals pi over 2. So the first thing you should do is actually graph this. So I have the graph over here because it would have been messy for me to draw it out. So you see here, it's only up to pi over 2, so that's where it stops, even though the graphs would have continued forever. You have to find the point of intersection because sometimes, most of the time, you'll have two functions, f at x, and it's always bigger than g at x, and you find the area between them. Other times, f at x is bigger than g at x in some places, but then g at x becomes f greater than f at x in other places. In that case, you have to split it up, find area 1, where one function is bigger than the other, then you find area 2, where the other function is bigger than the first function, and you add up those areas together. So, what we can do, since it's already graphed, we're just going to go straight to writing out the integrals for it. I'm going to change my color. So normally we will write it out like this. Area is equal to 0 pi over 2. So normally you'd write it out like this if it's not a question where you have to split the areas up. Okay, so this, you can't actually evaluate this because we would have to split our areas up, but you would write it like this. Sine x dx equals area 1 plus area 2. So this is signifying that you need area 1 plus area 2 to evaluate specifically for this question. So now we're going to write out our integral formula. We're going to split it up now. So from 0 to pi over 4, as you can see on the graph, that's why we found the point of intersection to see where one graph is going to be greater than the other, and then the other graph is going to be greater than the first, and so we know where to split it up. So we would split it up at pi over 4. So from 0 to pi over 4, it is cos x minus sine x. So you always take the bigger function minus the smaller one. So only in this blue region, area 1, we're going to have cos x minus sine x, because cos x is greater. So we have that, and then that's area 1, plus, we're going to change it to green, integral from pi over 4, because now look, from pi over 4 to pi over 2, sine x is going to be bigger, so we're going to take sine x minus cos x. Okay, so now we have the bigger function, sine x, minus the smaller function, cos of x. Okay, dx. Now we're going to actually take their antiderivative. So I'm going to switch back to blue, equals. Now the antiderivative of cos x is going to be sine x. So these are rules you should know by now. Sine x plus cos x. So I took this antiderivative, so you don't need the integration symbol anymore. And this is from 0 to pi over 4. Now I'm going to switch to green. Okay. So now, same thing with this side. You're going to take the integral of sine x minus cos x, which is going to become negative cos x minus sine x. And the dx disappears because you did the derivative. Oh, and I should have written dx over here. Okay? So you have that, and this is going to be from pi over 4 to pi over 2. Pi over 4 to pi over 2. Okay, so now when you evaluate it, you're going to do the upper limit minus the lower limit. So you're going to do from pi over 4 to 0. So sine pi over 4 plus cos pi over 4 minus sine 0 plus cos 0. So you're going to do those plus, now I'm going to switch to green. For this one, you're going to do upper limit minus lower limit. So you're going to do from pi over 2, so negative cos pi over 2 minus sine pi over 2 minus, actually, cos pi over 4 minus sine pi over 4. So you're going to get, which is going to equal 0 minus 1 minus negative 1 over root 2 minus 1 over root 2 this. You can do it, it's just going to end up being the same thing twice. So when you add all this up, you should get negative root 2 plus 2 over root 2 twice. You'll get the same thing twice. So I'm just going to multiply it by 2 and leave it at that because I'm running out of room. When you end up with your answer, you should get negative 2 root 2 plus 4 over root 2. Some books or textbooks or anything, it might have written out differently if it rationalized it. But one thing you can do is just put this number into the calculator, and if you see a different version of the answer online, you can put that number in a calculator and just compare them and see if it's the same thing. Okay, so that's how you do it.